Welcome back. This is an Aleks homework video on calculating the Gibbs free energy from the reaction enthalpy and the reaction entropy. Okay, all of these terms seem very confusing, but they're really just relationships between available energy in a system. Is the energy that's in the form of heat available to do anything, to do work with? So it's really just a relationship, and there's an equation for that you can use. It's not that mind-numbing if you remember the equation. So we have that the Gibbs free energy is related to the enthalpy and the entropy via this reaction. Now the minus T here is in Kelvin. So be careful, you have to put that in Kelvin for any of this math to work. And then you fill in the rest. Then they're going to ask you what the Gibbs free energy is in kilojoules. Now notice that the entropy is in joules per Kelvin, not kilojoules per Kelvin. You have to remember that. And that the Gibbs free energy is in kilojoules. So there's just a few things to have a red flag about. So as I'm going through it, I simply filled in what they're asking for and found that my delta G was negative 0.12665 kilojoules. But they're asking for 0 decimal places. That gives me that the Gibbs free energy is 0. And I remember that if it is 0, then the ammonia going to the N2H4 is not spontaneous, and the reverse reaction is not spontaneous. Neither is spontaneous. There's no available energy for that spontaneity, I guess. Okay? If you were to find a Gibbs free energy that has a negative G, then it is a spontaneous reaction, and if you have a positive G, then you can be convinced that the reverse reaction is spontaneous. Okay, so in this case, I've got 0 kilojoules for Gibbs free energy, and neither is spontaneous. That's the first problem. Second problem is not asking for Gibbs, but asking for the entropy. And so I just rearranged the formula. I put in the same information that they gave me, and I found that the entropy was 0.425 kilojoules per Kelvin. Now, you're not going to trick me that easy because entropy is not asked for in kilojoules. It's asked for joules per Kelvin, so I switched it before I wrote the answer down. And please do that. I also remember that in this case, I've got a positive G. So my G here is 18 kilojoules, and since it's positive, a positive G means that it's a spontaneous in the reverse reaction. So my entropy was 425 joules per Kelvin, and since I have an 18 kilojoules free energy, it means that the reverse reaction is spontaneous. So even though this is hard stuff, I think that in this particular question, I think you can do it. It's not that hard. I hope that this helped you.